How many of you have ever been down to Fort Myers Beach or Sanibel or down to Naples and you've been on the beach with your family and you have made some masterpiece of art out of sand on the beach? Maybe you carved your initials or your name in the sand, or you made an amazing sandcastle with mom or dad or brother or sister. You got everything just set, and maybe you went on a walk or went and had some lunch or some dinner and came back to your little camp on the beach, and your masterpiece was nowhere to be found. It was completely washed away. Has that ever happened to you? It has not happened to me, but it has happened to my children, and it's been devastating. So, we are going to talk about why that happens today, and you probably may already know what is one word that can explain what happened to your masterpiece. Do you know? The word is tides, okay? We're going to talk about tides in this lesson, so you can go ahead and get your textbook out, or if you don't have your textbook, that is fine. I'm going to just show it on the screen here and you can follow along, and we're going to give some illustrations to show what causes high tides and low tides and spring tides and neap tides and gravitational pull of the sun and the moon and the alignments that we've learned about and the moon phases that all affects what's going on with tides. So let's go ahead and open our books and get started. Okay, so the first vocab word is going to be tide, the periodic rising and falling of the surface level of the ocean. All right, let's start reading at the top of your page here. Have you ever stayed at a beach all day and wondered what caused the periodic rising and falling of the surface level of the ocean? I know you guys have all done that. Tides are mostly the result of the moon's gravitational pull on different parts of the earth. All right, so the moon's gravitational pull is what is causing those tides. Even though the sun has a greater mass than the moon is much closer to the earth. Okay, let's stop for a second. Remember when we were talking about the motion of the earth and the moon, we talked about things like gravity, inertia, mass, and distance all affecting that. So we decided that the greater the mass, the greater the gravitational pull. However, the greater the distance, the less the gravitational pull. So you would think that maybe the sun would cause the tides because the sun is larger. It's a larger mass. There's going to be a larger pull of a higher pull of gravity. However, the moon is so much closer to the earth than the sun. So the moon is actually what has a greater pull of gravity on the water on the Earth's surface. So this proximity of the moon makes the moon's force of gravity the main factor that causes the Earth's tides. All right, let's keep reading. Ocean waters continually rise for about 6 hours, and then they fall for 6 hours. So the high tide occurs on 2 points of the Earth at a time, and the low tide does the same. So the side of the Earth that's closest to the moon experiences a high tide. And interestingly, the side that is opposite the moon, the side that is farthest away from the moon, also experiences a high tide. Now, why in the world would that be? We just said mass and distance are the things that affect gravity. So it makes sense that the water on the side closest to the moon would have a high tide. Well, then why would the position on the earth, if you were on the opposite side of the world, why would you also be experiencing a high tide at that same moment, even though you are the farthest away from the moon? All right, we're going to discuss that. It's really interesting. Okay, but let's keep reading to the end of this page, and then I'll explain why that happens, and I'll kind of illustrate it. Low tide occurs on the sides that are farthest away and between the high tides, since the water is being pulled towards the high tides. Okay, so closest to the moon, furthest away from the moon, those are the high tides, and then the opposite places on the earth are the low tides. In about a 25-hour cycle, most locations on the Earth's surface experience 2 high tides and 2 low tides. All right, guys, here is our very interesting Earth, and here is our moon. Check that out. That is my daughter's lip gloss. But not really. It's chapstick. Chapstick, sorry, it's chapstick. But this is going to be our moon. It's the best thing I could find. Okay, so here's what we've got. We've got the moon, which is revolving around the earth, right? Not rotating. The moon rotates, but also revolves around the earth. Okay, so here we've got the earth. Here we've got you on the earth, on the beach. Okay, so here's what's going to happen. All right, when the moon is here, the moon has a gravitational pull on the water of the earth, right? So here is our water getting pulled toward the moon, right? So that would be high tide if you were on the beach. So the question was, how are we getting a high tide all the way over here on this side of the earth when it is the furthest away from the moon? Here's what happens. There's also a slight pull of the moon on the actual earth. So it's actually pulled the water that's closest to it. Then it's also going to pull slightly on the earth. So the earth moves a little closer to the moon and it leaves this water behind because it is the furthest from the moon. All right, so let's do that one more time. So you've got the earth and the moon. The moon is going to have a gravitational pull right here on the water that is closest to it. It also has a gravitational pull on this part of the earth that is closest to it, leaving the farthest point, being the water, the farthest behind. So now you've got a high tide on the opposite sides of the earth. All right, now remember, the earth is rotating on its axis. So if you are here at noon, all right, this is a 2D object. Obviously, the earth is not two-dimensional, but we're just going to use it this way for ease, but this isn't exactly how it's happening. But if the earth is rotating, 6 hours later, if you were here at noon, it is now 6 p.m. and you have a low tide, right? Right here again, if it is midnight, then there's a high tide. And if you rotate again, at 6 in the morning, you would be at a low tide. So every 12 hours, you're going to have the same tide that you were. So if you're at a high tide at noon, you have the next high tide at midnight. All right, so if I were, let's do it this way. If I were here, and if it were noon, and I built a sandcastle on the beach, I'm right here, it's noon, right? I have a great beach. I walk away at noon, I have lunch, I go do some activities with my family. When I come back 6 hours later, all right, 6 hours later, what's going to happen? Will I be at a high tide or a low tide? 6 hours later, here's what happened. The earth rotated, and I'm now at a high tide. My sandcastle is most definitely disappeared. All right, so we are going to talk about two special kinds of tides to wrap up this lesson. So we are going to move over to page 147 in your textbook, and let's read there. It says the average distance between the sea levels of the low tide and the high tide, okay, so every 6 hours, you know it's changing. So what is the amount of change that happens? It says the average distance is between 6 to 10 feet, all right? That's quite a bit of distance. However, when the sun, the earth, and the moon all line up, right, so that would be a new moon or a full moon position, when they're all lined up, the high tides are higher than normal, and the low tides are lower than normal. The maximum range between the high and the low sea levels results from both the sun and the moon exerting a gravitational pull on the earth in the same direction. This condition is called spring tide, and I will illustrate this for you in a second. Spring tide coincides with the approximate time of full and new moon phases, when an imaginary line between the Earth and the moon creates a right angle with an imaginary line between the Earth and the sun. A neap tide occurs. During the neap tide, high tides are lower and low tides are higher than normal because some of the Earth's gravity and some of the moon's cancel each other out. The smallest difference between tide levels takes place close to the first and third quarter moon phases. Both spring and neap tides occur twice a month. All right, that makes sense because once a month you'll have a full moon and once a month you'll have a new moon. So 2 times a month you are going to have a spring tide, and then you have a first and a third quarter. So 2 times a month you're going to have a neap tide. Let me show you with our illustration here what spring tide and neap tides actually are when you're looking at. All right, so let's look at spring tide and neap tide and what that means. Okay, so we have our moon here, and we have high tides happening, right, where we are on Earth. So here's high tide on this side, high tide on this side. Now, where the sun's position is, remember we have the sun. The sun is also exerting a gravitational pull on the Earth. So where the sun is in this situation also affects the tides. So for instance, if the sun were right here, okay, we should already know what kind of a moon this is. If we have the Earth here, the moon here, and the sun. So this back half of the moon is lit. That means it's a new moon if you're standing here on the Earth. You're looking up in the sky and it looks as if there is no moon because only the back side is lit because of the position of the sun. All right, so what's interesting is during this new moon time right here, if this is the alignment of the Earth and the moon and the sun, you have an extra pull. Look, you've got the moon here pulling a gravitational pull right here on this water and on the Earth, causing this high tide. But now you've got the sun backing up the moon. So you have an extra high tide. That is called a spring tide. It means the moon and the sun have now doubled up and they're both pulling. They both have a gravitational pull. So these tides are extra high. And the low tides over here are going to be extra low because it's pulling even further. All right, but what happens when the Earth revolves around the sun, which I'm going to actually make the sun revolve around the Earth just because it's going to be easier for my situation. But what happens when the sun is right here? Now you've got the sun pulling the gravitational pull this way, and the moon is pulling this way. So these high tides are a little bit lower than normal because the sun is actually working opposite of the moon. All right, so that is called a neap tide. A neap tide, they're not quite as high and they're not quite as low. Spring tide, they're doubled up in their power. So high tides higher, low tides lower. And that works on this side too. When you've got a full moon, right? So if the sun were here, now they're both pulling this direction a little bit extra, all right? So you've got this moon that's pulling extra on this, and this sun is pulling extra on this. This is spring tide. This would be, if it were down here, it would be a neap tide. So just remember, spring tide is when the highs are higher, the lows are lower, and in order for that to happen, you've got to have the sun and the moon lined up in a straight line. And when they form an L like this, then they're not going to be quite as high. That is a neap tide.